So we're going to do a couple examples. Howard can never remember what kind of drink he is supposed to get for his wife from the coffee cart on the street. The coffee cart has 5 different hot coffee drinks, 2 different hot tea drinks, and a frozen coffee slush. Harold decides to randomly choose 2 drinks. When he sees his wife, he learns that she wanted a hot coffee drink. What is the probability as a percent that Harold chose at least 1 hot coffee drink? Make an area model or a tree diagram to justify your solution. So, on his first coffee drink, Harold has 3 choices. He has a hot coffee drink, he has a hot tea, and he has a frozen coffee slush. Of the drinks he has available to him, 5 of his coffee drinks are hot, 2 are tea, and 1 is a frozen coffee. So 5 plus 2 plus 1 gives me 8. So these are all out of 8. Now, those are his choices for his first drink. His second drink has the same choices. He can either get hot coffee, he could get hot tea, he could get a frozen coffee. And we're just gonna close it. Okay. Now, his probabilities are the same. He still has 5 out of 8 for hot coffee. He still has 2 out of 8 for hot tea. He still has 1 out of 8 for frozen coffee. Now, for each of these, to find the probability he gets hot coffee and hot coffee, you're going to multiply. So 5 times 5 is going to give me 25. And then 8 times 8 is going to give me 64. 5 times 2 is going to give me 10. And 8 times 8 is going to give me 64. 5 times 1 is going to give me 5. And 8 times 8 is going to give me 64. So now you'll notice these are all out of 64. And if you notice, we have all denominators of 8, so all of them are actually going to be out of 64. So now I have 2 times 5, which is going to give me 10. And then 2 times 2, which is 4. And then 2 times 1, which is 2. And then 1 times 5, which is 5. 1 times 2, which is 2. And then 1 times 1, which is 1. So you can check to see if you did it right by seeing if your numbers all add up to 64. 25 plus 5 is 30, plus 10 is 40, plus 10 is 50, plus 10 is 60. Oops, I missed something. Sorry. 10 and then 4. So they add up to 64, so we know that we did all our math correctly. So now we need to focus on the ones where we're talking about hot coffee. And she only needs 1 coffee. So we're talking about anyone where she has 1 or 2 coffees. So all of the ones up here, which have hot coffee as the first one, all of those count, because all of those have at least 1 coffee. And you even get 2 up here. Now for my second bracket, it's only this first one that's going to count, because that's the only one that has hot coffee included. And then for this third one, again, it's only the first one that's going to count, because that's the only one that has hot coffee. So now, to figure out the probability that any of these situations occur, we're going to add them up. So I have 25 out of 64, plus 10 out of 64, plus 5 out of 64, plus 10 out of 64 plus 5 out of 64. Now I know we all remember that the denominators when you're adding denominators of a fraction, they have to be the same, which these are, and then the denominator stays the same. So it's going to be out of 64. So I have 25 plus 10 is 35, plus 10 is 40, plus 10 is 50, plus 5 is 55. Now hopefully you caught me say that as a percent, so 55 out of 64, we need to figure out what percentage that's going to be. So we take 55, we divide it by 64, which is 0.859375. If you move the decimal place over 2 spots, it's going to be 86%. So remember, we multiplied to get our probabilities of the ands, and then we added all the different probabilities that go together. So now for my next instance. Denise also goes to this coffee cart. In addition to one drink, she chooses a bagel. The cart has 8 plain bagels and 5 blueberry bagels. She can top her bagel with cream cheese or butter. If she randomly chooses a drink, and a bagel, and a topping, what are all the possible combinations in the sample space? Use the abbreviation CTF for the drink, and P or B for the bagel, and CR or BU for the topping. So we'll do that part first, and then we'll come back to the second part. So for her first probability, we've got C, T, F. And it was 5 out of 8 for coffee, and it was 2 out of 8 for tea, and it was 1 out of 8 for frozen coffee. She then has 2 types of bagels. We've got plain and blueberry. And there were 8 plain and 5 blueberries. So we got 8 and 5. 8 plus 5 is going to give me 13. Yep. All right, and so we have that for all of them. All right, so now our last choice, we have toppings. Butter or cream cheese. And they didn't give us probability, so I'm going to assume it's just half and half. All right, almost done. We're not going to worry about multiplying all those probabilities out for now. Denise likes hot tea and blueberry bagels. So the first one is the union, which means that she gets either hot tea or a blueberry bagel. So we're going to go through and highlight every single one where she gets hot tea. So we're going to start off right here. All of these are hot tea. Doesn't matter if she gets a plain bagel or a blueberry bagel. So now at this top one, she's not going to get hot tea, but she will get a blueberry bagel for both of these bottom ones. And then for this bottom one, she's still not getting hot tea, but again, she's going to get a blueberry bagel for some of them. So the union, we've got 1, 2, 3, 4, 5, 6, 7, 8. So she's got 8 possible combinations. Which outcomes are in the event hot tea and a blueberry bagel? So those are the ones where we're looking for that they have both occurring. So we're only looking at our T branch, and we're only looking at our blueberry bagels. So those we just have 2 situations. You've got tea and a blueberry bagel. So these are very obviously not the same. You can see that there are a lot of possibilities when it's one or the other, and there's not that many possibilities when it's both. Now really quickly, we're going to calculate the probability for tea and bagel, and you'll see why in a second. So we got 2/8 times 8/13 times 1/2. 2 times 8 is 16, times 1 is still 16. Oops, I'm looking at the wrong one. try that one more time. 2 times 5 is 10. So we got 10 out of 8 times 13 times 2. I'm going to pull up my calculator for that. Which is going to be 208. And then we've got 2 times 5, which is 10, times 1 is still 10, and it's going to be out of 208. So then to figure out the probability that she gets either of those, we're going to add that. So I've got 10 out of 208 plus 10 out of 208, which is going to give me 20 out of 208. And you'll see why I did that in a second. So when you go to example 3, Denise is randomly handed a drink bagel topping combination by the coffee cart owner. Use a complement. So a complement is the stuff that isn't included. So find the probability that Denise was not handed a hot tea and a blueberry bagel. So we're figuring out the probability that she doesn't get her favorite option. And hopefully you remember, complements add up to 100% because you're either in the event or you're not in the event. So 100% is also 1. And so we're just going to subtract our previous probability, which was 20 out of 208. I'm going to double check that. Yep, 20 out of 208. I'm going to rewrite 1 as 208 out of 208. So we're going to subtract them. Just like with adding, when you're adding fractions, your denominator stays the same. So we've got 208 minus 20, which is going to give us minus 10 would be 198, minus another 10 would be 188. And since we want to figure out what that percentage is, we're going to take the calculator out again. 90%. So she's probably not going to be happy with what she's given, since she's getting that, or there's a 90% chance she doesn't get what she likes. All right. So those are all of our major examples. I've got one more example for you to look at today, which is a little shorter. Zoe's grandfather has purchased her a kit of 75 assorted pieces of seashell life. The kit has equal numbers of gastropod seashells, bivalve seashells, sand dollars, sea fans, and starfish. So we have 75 total things. And out of those 75 things, you have 1, 2, 3, 4, 5 choices. So when I take 75 and divide it by 5, I get 15. So there are 15 of each of those. Each of those sea life are divided into equal numbers of large, medium, and small objects. So I've got 15 for each one, and of each of them, they're in 3 groups. So there's 5 of each type. Zoe is creating a piece of display art with the sea life. To start the artwork, Zoe selects a random piece of sea life. What is the probability she picks a small seashell? So for seashells, we've got 2 choices. So there's 30 seashells, because you've got 15 that are gastropods and 15 that are bivalve. Of those 30, 5 of them, 5 of each, are small. Because 5 plus 5 is going to give us 10 out of our total number of 75. So she's got a 10 out of 75% chance that she picks